So I want to take a look at a linear transformation where we're asked to find the mean and the standard deviation of the combination of two random variables. So we have X is the number of Pete's passengers. We have Y is the number of Aaron's passengers. Now let's suppose that Pete charges $150 per passenger and Aaron charges $175 per passenger. And we've got their summary statistics, which we saw previously. Now we want to calculate the mean and the standard deviation of the total amount of money that Pete and Aaron collect on a randomly selected day. So first, let's write out the equation for a new random variable, t, where t is the total amount of money collected on a random day. So t is going to represent the total amount of money that's collected, and it's going to be 150 times x, number of Pete's passengers, 175 times number of Aaron's passengers. So really what we're doing is we are transforming x and transforming y and then adding them together. So we want to find the mean and the standard deviation of this new variable t. So all we're going to do is we're going to take the mean of Pete's passengers, multiply it by the amount he will make. That's how much we would expect him to make, and multiply the mean of Aaron's passengers times 175, and that'll be the expected amount that she makes, and we'll just simply add them together. And so the expected value is 1,105, which means Pete and Aaron will expect to collect a total of $1,105 per day on average over many, many randomly selected days. So it's the average that they will get together over many, many selected days. Now let's find the standard deviation of the combination of 150 times x plus 175 times y. We should remember that we are never going to add standard deviations together. So what we need to do is we need to find the variances of the transformed random variables. So this is the way I want you to think about it. To find the variance of their total amount collected, we have to add the variance of Pete's money plus the variance of Aaron's money. So we don't right now have the variance of Pete or Aaron's money. We have the standard deviation of the number of passengers. And so what we're going to end up having to do is we're going to have to multiply the standard deviation by 150 and multiply her standard deviation by 175. And those will give us the standard deviations of their amount of money collected, but we need to then convert them to variance to add them together. So we're going to multiply the standard deviation by 150 and then square the resulting value, and then add that to the variance of Aaron's. So you can see I'm going to multiply Pete's standard deviation by 150 and then square that to get the variance of Pete's money and add it to 175 times Aaron's standard deviation and square that to get the variance of the amount of money Aaron will collect. Then I can add their variances together and I get the variance of T to be 53,950. To get the standard deviation, I simply take the square root of this value. But instead of taking the square root of this, I want to take the square root of the entire equation because this is a rounded value and I don't want to round until my final answer. So we get a variance or a standard deviation, of 232.27, which is interpreted as the sum of the amount of money collected on a randomly selected day typically varies by $232.27 from the mean of $1,105. So the sum of the amount of money on a randomly selected day typically varies by $232.27 from the mean sum of 1,105. So this example is an example when we have to do a linear transformation. So we are transforming x and we're transforming y and then combining them. But I want to show you one more example with the same exact data set, but now they have already transformed x and y. So we want to find the difference between the number of Pete's passengers and Aaron's passengers. And now they're going to say C is the amount of money that Pete collects, and G is the amount of money that Aaron collects. So really what they're saying is they've already done 150 times x. They've already done 175 times y, because this is another way we could have done the previous problem. So here we're going to do this for the difference, calculate the mean and standard deviation in the amounts of money, and interpret each value in context. So we want to find the difference in the expected amount that Pete collects, subtracting the amount that Aaron collects. And so to find the mean, we're just going to simply subtract the expected collection from Aaron's from Pete's. And I want you to notice that I've used the expected value instead of mu. I want you to be used to the symbols are the same. So it's the expected value of C minus the expected value of G, which is just going to be the mean minus the mean. So as you can see, the expected value of the difference is $20 subtracted their means. And interpreting this is saying that Pete and Aaron expect to collect a $20 difference when subtracting Aaron's from Pete's per day on average over many randomly selected days. Another way you could say it is if we randomly selected many, many days, then we'd expect the average difference to be $20 when subtracting Aaron's from Pete's amount collected. Now let's move on and find the standard deviation. And so since they've already done the transformation, they've given us the standard deviations for Pete and Aaron. And as we know, whenever we are subtracting or adding, we're going to add their variances together in order to find the standard deviation for the difference. So the variance will be the sum of the variances, and I'm going to have to take the square root to get the standard deviation. So 163.46 squared will be the variance for Pete's amount, plus 165.03 squared will be the variance for Aaron's amount. Add them, take the square root, and that will give us the standard deviation. So you can see when I add their variances together and take the square root, I get the same value that we had before, $232.27. So whether we're adding them or subtracting them, should be reminded that we are going to get the same standard deviation when combining the variables. And so the interpretation will be the same, but this time it's about the difference instead of the sum. So the difference in the amount collected on a randomly selected day typically varies by about $232.27 from the expected difference of $20. So the two main takeaways from this video is that when we are combining two random variables, we always add their variances and we never add standard deviations. And whether we are adding or subtracting the independent random variables, we always add their variances.